So this is the integral test on binomial distribution, question 7. And as you read through the question, you'll see it's one nice and relatable for teachers. Anyway, we've got Mr. Buller, and he's got his favourite car parking spot. And key thing is that he gets it on average 1 day in 3. So the probability of his getting it is 1/3. And we're reminded that a working week has got 5 days in it. Now, part A. In order to use the binomial distribution, we need more than a probability and a number of trials. There's some other conditions as well. We need to know that there are 2 possible outcomes for each trial, usually referred to as success or failure. There needs to be a fixed number of trials. So far we're fine on these 2 outcomes. He either gets his parking place or he doesn't. Number of trials is 5 in a working week. Now those trials, they need to be independent. So in other words, if Mr. Buller has parked in the same spot 2 days running, does that mean that other people are less likely to try and get it? Well, we assume that's not the case. That's something that we need to assume. And another condition for it being binomial probability is that the trials are identical. So in other words, it's the same probability each time. For this one, we're told that the average is 1/3, so I think it's safe to assume yes, the probability isn't changing. So, independent is our answer for part A. Now for part B, we're told to calculate the probability that he gets his favourite spot at least twice in a week. So what we're finding there, we're finding the probability that x is at least 2 greater than or equal to 2. So x is approximated by the binomial distribution with number of trials 5, and the probability is 1/3. And so we can put those, so to find the probability is greater than or equal to 2, to use our calculators, we find 1 minus the probability of the inverse, so that it's less than 2, in other words less than or equal to 1. So that's 1 minus 0.4609, and that equals 0.539 to 3 sig figs. Let's have a look at question C then. So it's a 7-week half term. It's a good week if he parks in his favourite spot more than 1 day in the week. So what we're talking about is 2 or more. So we've found the probability of it being a good week already in part B. So in part C, we're asked to find the probability that he has more good weeks than bad weeks. So if there's more good than bad in a 7-week term, then what we're saying is then there's at least 4. So we're using the binomial distribution. So there's 7 weeks, and the probability of success is 0.539. So if we're finding the probability of this, then that's equal to 1 minus the probability that it's less than or equal to 3. Now it's in the less than or equal to form, then we can find the value from our calculators. And that equals 0.585.